In the table above, we talked about how the sign of f prime of x can tell us about the behavior of f of x. In particular, if f prime is positive, that means that our function f is increasing. And if f prime is negative, then that tells us that our function is decreasing. So we're going to look at an example here where we can use this information, use the sign of the first derivative to tell us whether our function is increasing and decreasing, and then eventually use that to sketch a graph of the function. So here we've got a function f of x equals 8x minus x squared. We're going to start off by finding the x values where f of x has a horizontal tangent line. So just to very quickly recall, remember when we're thinking about a tangent line, we're talking about f prime, so we're thinking about the derivative. And when we have a horizontal line, I know that the slope of that is 0. So I'm going to take the first derivative and set it equal to 0. So first we'll find f prime of x. So here in part A, f prime will be equal to 8 minus 2x using our power rule. And then I'm going to take that first derivative and set it equal to 0. And now at this point we can just solve for x. So let's see, I'll add 2x to each side, so 8 equals 2x, and then divide by 2, so that means that x is equal to 4. So at x equals 4, I know that I have a horizontal tangent line. And we'll see what that looks like in the graph of f of x in just a minute. But I'm going to use this piece of information now in the second part of my question, because now it's going to ask us where is f of x increasing and where is this function decreasing. Well, we said over here that the sign of the first derivative, f prime, will tell us whether our function is increasing or whether it's decreasing. So I know, based on what I found in part A, that at x equals 4, the first derivative is 0. So it could change sign at 0. So what I'm going to do to help me organize my information here is I'm going to create just a little number line here. So I'm going to create a small number line. Here's f prime. And I know that the sign could potentially change here at x equals 4. So I'm going to include 4 on my number line. And then what I'm going to do is I'm going to use this to help me organize the information I know about the sign of f prime of x. Now, we just said that when x is equal to 4, f prime was equal to 0. So before I do anything else, I'm just going to put a little 0 right above 4, and that's me saying, hey, f prime is equal to 0 at x equals 4. So that'll come in handy when we get to our last step, when we want to graph this function. So now what I'm going to do is I've essentially taken my number line and I've broken it up into two separate intervals. I've got this left-hand side of 4, which if you wanted to write that as an interval, would be -infinity to 4. And then I have this right-hand side of 4, which if I wanted to write that as an interval, I would say 4 to infinity. Be careful, remember 4 is not going to be included in either one. 4 is not going to be included in either one of those two intervals because we're separating by 4. So what I'm going to do is I'm going to take an x value in each one of these intervals and plug that into my first derivative to determine the sign of that function. So I'm going to look, first of all, I can pick any x value between -infinity and +4. So I could pick x equals 3, I could pick x equals 2, I could pick x equals 1. It doesn't particularly matter as long as it lives between those numbers. I'm going to work with x equals, and I'll do my work over here, I'm going to work with x equals 0 just because it makes the computations easy. So I'm going to take that number and plug that into my first derivative that I found in part A. So at x equals 0, f prime of 0 is equal to 8 minus 2 times 0 gives me 8 minus 0 gives me 8. And remember, I'm really interested in the sign of this number because that's what tells me where my function is increasing or decreasing. Here we ended up with a positive 8. So what I'm going to do is on that interval, so remember we chose that number from the left-hand side, I'm going to put some plus signs over there to remind myself, hey, the first derivative is positive on that left-hand side. Now, it doesn't particularly matter, like I said, what number we chose. You could have chosen, let's say we chose x equals 1 instead. If I were to take that number and plug it into my first derivative, f prime of 1, that would be 8 minus 2 times 1 gives me 8 minus 2 gives me 6. Now, I ended up with a different number here, but I still have the exact same sign. It's still a positive 6. So what number we pick within this interval is not particularly important because the sign is going to be the same no matter what number we pick within that interval. So I have the left-hand side taken care of. We got to do the right-hand side now. So I'm going to pick a number in between 4 and positive infinity, or you can think about that as a number on the right-hand side of 4. So I'm going to pick x equals 5. And again, I'm plugging that into my first derivative, which we found in part A. I'm going to plug x equals 5 into f prime of x. So let's see, f prime of 5 is equal to 8 minus 2 times 5. Here we've got 8 minus 10, and then when I subtract those two, I end up with a negative 2. So that means on the right-hand side of 4, I'm going to have a negative value. So I'm going to put some minus signs on that right-hand side of 4 to help me remember, oh, the first derivative was negative on the right-hand side of 4. And now, at this point, I've got everything I need to answer this question because I can go back and I can remember, well, remember that let me erase some of this highlighting here. Remember that the first derivative sign can tell me whether it's increasing or decreasing. So when f prime is positive, that means that our function f is increasing. So I can look and I can say, well, we said our first derivative was positive on the left-hand side of 4 or on negative infinity to positive 4. So that means that our function f is increasing on negative infinity to 4. And then, well, what if it's negative? I can scroll back up and I can say, well, we said when f prime was negative, that means that f is decreasing. So that means wherever f prime was negative, which was on the right-hand side of 4, or on the interval 4 to infinity, our function was decreasing. So that means that our function is decreasing on positive 4 to positive infinity. So here is where our function is increasing, and here is where our function is decreasing. So this sort of gives us a template, kind of a rough outline for how we can determine where a function is increasing and decreasing. And that can be really, really helpful when we want to, say, sketch the graph of a function. So that's actually the last thing that I'm going to do here. In part C, I want to sketch a graph of f of x. So right now, when we're sketching graphs of functions, I don't need the graphs to be super detailed. Generally, I'm only going to be looking for a handful of important points, and we'll talk more in this section about what points we consider to be important. I look at this, and I see, first of all, that the function is changing from increasing to decreasing at x equals 4. That seems like a pretty important point to me. So I'm going to go ahead and find what is my function at x equals 4. X equals 4 seems to be an important point. Well, I want to know the y value of my function at x equals 4. So in order to find that, I'm going to take x equals 4 and I'm going to plug that into f of x, my original function, because that's what tells me the y value. So we have 8x minus x squared. So I want f of 4 is equal to 8 times 4 minus 4 squared. Here we should have 32 minus 16 ends up being a positive 16. Remember, this is my y value. So I'm going to go ahead and put a point at 4 comma 16. 4 comma 16. So I'm just going to label my y-axis by 2's really quickly. 2, 4, 6, 8, 10, 12, 14, 16. And I'm going to go ahead and put a point right, oops, put a point right, right about here. Now, before I do anything else, I do think that having this horizontal tangent line, remember the very first thing we did in this problem was find out where we had a horizontal tangent line, and we said that was happening at x equals 4. I like to include that before I even sketch in the rest of my problem. So I'm going to include a horizontal tangent line right here. It's not part of my graph, but it will help me shape the rest of my graph. So I have a point right there, and then I can look at this function and I can say, well, it's increasing, so that means it's going up from negative infinity, so all the way over here at x equals negative infinity until I get to 4, until I get to this point, and I know that I need to reach this point right here. So it's going to be increasing, 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 but I need to level out because I need to hit that horizontal tangent line. So that's what the left-hand side of my function looks like. On the right-hand side of 4, we said there it's decreasing. So that means here my function needs to go down. So this gives me kind of a rough outline of what my function looks like, and I can actually kind of check with what I know. This looks like an upside down parabola here in this case, and I can look at the type of function that I began with. Well, here we have a quadratic function. The leading term is negative. So that means, yeah, we should have an upside down parabola. So that means that all of our work was correct. Now, this is a relatively simple function. We could have graphed this using what we know about quadratic equations and vertices and things like that. But what's really cool is we can kind of take this process and expand it so that it works with more complex functions. What if we're working with, say, cubic functions or quartic functions or root functions? We can do some really, really cool stuff with calculus, and that's going to be what we're focusing on in this chapter, is how can we use the first derivative to help us understand the graphs of functions and the behavior of our functions.